Hi guys, in this video we are going to discuss another interesting question from vector. We have already posted many videos regarding vector in Expert Tutor channel. If you like to watch them, please subscribe. Also, we have given the link in the description so you can always watch that. In this question, they are given three vectors AB, AC and AD, and they are asking whether these three vectors are in the same plane. Or in the other terms, they are asking find that these three vectors, or show that these three vectors are in the same plane. So how to show that? But here we knew the three vectors are taken from a common point A, and these vectors, they are given the whole equation of those three. So we need to find whether these are in the same direction. For that, we are going to use the triple scalar product. So this is the idea. So why are we going to use that? Before watching the rest of the video, please try to do it in your own. After that, watch the rest of the video, so it would be more useful for you guys. Okay, let's continue this. So over here, the thing is, why are we taking the triple scalar product over here is, let's say there are two vectors. There is a vector called, let's say this is the vector AB and this is the vector AC. So let's say this is the point, so this is the point, so this is going to be AB and AC. Actually, we don't know what's the angle between these. Okay, what's meant by the triple product is, let's say this is the B vector and this is a C vector. So the triple product simply means B vector cross C vector into dot A vector, which simply means it's going to have the scalar triple product will have a cross product within two vectors. After that, we need to have the dot product with another vector. So we are going to have the triple scalar product over here and check whether these are in the same plane. Why are we using? The reason is, if we take the dot cross product between these two, it's going to return the vector which has a direction in the perpendicular to this plane. So that's the main idea. If we take a cross product between these two vectors, any two vectors, it's going to return the vector, another vector which is perpendicular, which is normal to this plane. Let's say this is the plane. So over here, if we take the dot product with another one, which simply means we are going to take another vector. Let's say this is a vector in this direction. Actually, we don't know what's this one. So if we take the cross product between BC, it's going to show in this lower direction. Actually, how to find that? You can use your right hand rule over here. If you move the four fingers from B to C in your right hand, it's going to show a point towards the paper. So it's going to be underneath, which means it's going to show in the below. Let's say this is an A vector. Actually, we don't know the direction. So the thing over here is, if we take the dot product between these two vectors, if the angle between these two vectors are 90, it's going to be in this direction. That's the reason. If the A vector and the cross product resultant vector, the dot product between these two vectors are 90, we can directly tell these three are going to be in the same plane. Actually, we need to do this one. So in this case, you can take any two vectors and do the cross product. After that, do the dot product with the resultant vector you have got from this cross product. So that's the idea behind this. If we take the cross product, it's going to return the vector normal to this plane, and if we take the dot product between these two, if this is 90, we can tell. If the resultant is 0, we can tell it's going to be 90, which simply means these three are in the same plane. So we need to check whether this 0 or not. So over here, let's take two vectors over here. So I'm going to take any two vectors. So let's say for the simplification, we can take this is P, Q, R. Let's say this like this. So I'm going to take cross product between P cross Q. So how do you get that? actually we knew that we need to draw a matrix ijk and minus 7. This is minus 5. This is going to be 0 as they haven't mentioned the k value, and we can write it like this: minus 1 plus 4 and 3. So if I take the cross product between these, it's going to return, let's say this is I j k. I'm going to write like this. If I take this one, minus 15, so it's going to be minus 15. And if I take the j part, it's going to be minus 21. Be careful, we need to use the minus if we simplify this matrix over middle part. So if we minus into minus 21, it's going to be plus 21. And the k part would be minus 28 plus 5. If we deduct plus 5 from minus 28, it's going to be minus 33. So now we have get the answer for this one. In the next part, we are going to take, this is the resultant vector, so we are going to take the dot product with the another vector, r vector. So I'm going to take like this, r dot p cross q. So if I take directly, let's say I'm going to write like this: minus 8 minus 1 plus 3 dot minus 15 21 minus 33. So if I do so, I'll be getting minus 8 into minus 15 would be a 90, I think, 30, 120. It's going to be 120. And if we take the dot multiplication with this, we are going to get minus 21. And if we take between these two, it's going to return minus 99, which simply means we are going to get 0, which means the resultant vector is going, sorry, that's not a vector, the resultant magnitude would be 0. From that we can directly tell that these three vectors are lying in a same plane. So in this video we have discussed how to show that any three vectors are lying in a same plane. If you have 4 vectors, you can do for first 3 vectors. After that you need to do for another 3 vectors, considering that 4th vector. From if they return the 0 value, you can directly tell like this one. So the minimum thing is you need to have, actually you need to have any 3 vectors over here to show that the 3 are in the same plane. So in this video, I hope this video would be useful for you. If you have any doubts, please comment it below. I hope you have already subscribed. Thank you.